It's day one, and torrential rain greets the crew of Maddie Inc. on what is to be the most rigorous testing of the longest Maddie aluminum bridge in the history of the company. And if the rain isn't ratcheting up the tension for Chief Engineer Alex de la Chevrotière and Control Designer Simon Lacasse, it's the expected arrival of the company rep that commissioned the bridge, who flew halfway around the world to scrutinize the testing process. The bridge has been ordered to withstand the harsh conditions of the swelling seas, connecting two offshore platforms in the middle of the ocean. The bridge must withstand weight well beyond its intended capacity, in this case 80 workers crossing the bridge at the same time. The name of these tests?
FAT test, Factory Acceptance Test. On the bridge that you see behind me, it's a 46-meter bridge long and 2 meters wide.
The overall bridge assembly weighed a little bit over 13 tons.
The crane on the offshore platform can only lift a maximum of 15 tons. A steel bridge of this length would be impossibly heavy. Finally, the client arrives. The surveyors are set, and after a quick inspection of the bridge, it's time to bring out the big guns. The water bottles have to be perfectly placed for weight distribution purposes. Alex walks the client through the process. This is no ordinary pedestrian bridge. This is a super bridge designed to handle the most extreme conditions. There is no room for failure. Usually, bridge structures are fixed, but not this bridge. A trolley enables one side to move back and forth, and both sides can rotate 3 degrees, which translates to 2.4 meters, to account for ocean movement. Both ends of the bridge use pin connectors that can each withstand an incredible shear load of 150,000 pounds. As the water bottles are loaded, precise measurements are kept to see how far the bridge bends, or its deflection under the load. The weld joints, the glue that in part holds the bridge together, have their own strict regulations, testing, and guidelines. So every joint is checked and checked again. Alex and his team are ready for the mother of all tests.
The positioning of each bottle is very important, so we get a uniformly distributed load on the bridge.
8.4 tons is loaded on the bridge, a whopping 432 water bottles, and so far, so good. There is a very important difference between a steel bridge and a Maddie aluminum bridge.
Elasticity of aluminum is 1/3 of steel. That makes very important to design properly the aluminum structure, because we can reach the natural frequency of the structure more easily than steel.
Day one testing has passed with flying colors.
The maximum allowable limit was limited to 256 millimeters. We did 50.
It's day two of the factory acceptance tests. But after yesterday's excellent results, Alex and his team are confident the weather won't factor in to today's inclination test.
Over there, we're checking the flexible connectors just to make sure their integrity is all right. And now we're gonna load down the abutment 10 inches, minus 250 millimeters, and we'll check on this side, on both sides, so the flexible connectors are intact.
The next step is to move the bridge laterally. The test simulates the expected 1 foot, or 30 centimeters, of movement between the two offshore structures during a storm.
The test carried out the last 2 days showed that the bridge performed very well.
The next few days will be filled with more inspections and disassembling the bridge into transport containers. Then, the bridge will make the long trip to the southern hemisphere, where it will be installed between the two offshore platforms. Bolt by bolt, the bridge is meticulously disassembled and packed into cargo shipping containers. Maddie Group has pulled off the testing with resounding success. But with results like these for the FAT tests, the bridge will serve its purpose outstandingly well. A superb example of the quality Matty Group brings to each of its builds. Matty Group, the experts in aluminum bridge design and build.